Hello students, welcome back into my channel. In this video I'm going to show you how we find the solutions of a past paper of Cambridge IGCSE, past paper physics, paper 3, theory core, number 062531 on October-November 2023. Let's start with number 1. Number 1, figure 1.1 shows a distance times graph for a cyclist. This is the graph. Question A. Determine the distance traveled by the cyclist between time 0 and time 100 seconds. Right. If you look at this graph, as long as 0 to 100, okay, and look at the distance in meters. Okay. The distance is this one, 400, because look, the straight line, the graph increase from origin to this coordinate point. So it means the distance traveled as long as 400 meters. Yeah, meters already here. And calculate the speed of the cyclist between 0 and time. It means, yeah, speed or velocity formula is distance times distance over time. So velocity or speed is distance 400 meters over 100 seconds. So we got 4 meters per second. Yeah. So the answer is 4. Now describe the motions of the cyclist between 100 seconds and time 250. If you look this graph, okay, increase from 0 to this current point, 400 and 100. After that, the cyclist stop as long as 100 to 150, and after that 150 to 150 to, let's check, 150 to 250 increase as well. Yeah. So so 0 to this to 100, it's steady. 100 to 150, it's stop or at rest, while 150 to 250, it's steady again. So I'm going to write down here at between 100 second to 150, it's stop or at rest, and between 150 second to 250 second, it has steady speed. Okay, next. B, figure Point 2 shows the cyclist riding along a long straight road, right? The speed of the cyclist is 15 meters per second, determine the velocity of the cyclist. The velocity, of course, 15. Yeah. Uh, yeah. If speed 15 meters per second, as well, velocity 15 meter per second. Now direction. Look, this cyclist. The cyclist uh, goes straight on to, yeah, this direction to the west. So it means direction to the west. Yeah, number 2. Number 2, I'm going to use another color. The mass of a solid metal cylinder is 400 grams and its volume 52 centimeters cubed. Calculate the density of the metal, include the unit. The density equals 400 grams over 52 centimeters cubed. So the result is 7.7 grams over centimeters cubed. So 7.7 here. The cylinder is falling at constant speed through the air. And look, this figure 2.1 shows the vertical forces acting on the cylinder. So we are going to fill in this point as falling at the cylinder is falling at constant speed through the air, or it means it is the air resistance. Air resistance. Yeah, it means this cylinder has friction, you know, frictions with air. So how about this? Write the name and the size of the upward force. Okay, upward force is air resistance or drag. Okay. And what else? On the cylinder. Okay. One is, let's to look. Oh, weight is 3.9 Newton. So it means this is the force is 3.9 Newton. Weight, it means 30. You have to calculate. It becomes 3.9. Yeah. Yeah. If you are going to find with you through this formula, m times g, right? And weight equals 3.9 newtons. See, the student balances a beam on a pivot. On the beam, he positions the cylinder on a block so that the beam remains balanced. The arrangement is shown in figure 2.2, right? So the questions calculate the weight of the block, right? The weight of the block. Okay. We are going to find cylinders. The rule first, that cylinders moment. equals block moments. So how we calculate the uh, cylinder moment? That it means block moment equals the cylinder moment is 97.5 Newton centimeters. Okay, big, yeah. So block moment is 97.5 Newton centimeters, and it means this is weight of block times 42 centimeters plus 97.5 Newton centimeters. So W block or weight block 97.5 Newton centimeters over 42 centimeters, and it is 2.3 newtons. So the answer is 2.3. Number 3, figure 3.1 represents the arrangement and separations of particles in a liquid. Each circle represents a particle. Okay. In the box in figure 3.2, draw at least 4 circles to show the arrangement and separations of particles in gas. I'm going to draw 5. 1, 2, 3, 4, 5. Okay, it was particle in gas. So describe the arrangement, separation, and motions of particles in solid. Okay. If in gas, the arrangement particles are widely spaced apart but different. With solid, in solid, the arrangement, I'm going to write down here. First, arrangement. Arrangement, solids, particles are arranged in a regular way. Okay. After that, separation. Solids particles tightly tightly packaged, usually in a regular pattern. Okay. And next, motion. Motion. The particles move around the fixed point. Okay. See, figure 3.3 shows a fire heating water in a metal pan. Okay. State the name of the process of thermal energy transfer through the metal of the pan. Oh, it is conduction. Yeah, because this process of conductions, because yeah, this is transfer of thermal energy between two objects by direct contact. Yeah, that's conduction. And what else? Yeah, describe how thermal energy is transferred through the water by convection, right? By convection, just now conduction, it is convection. So convections occur in water because the case that's on water because because water or liquid particles, because water particles or liquid particles at bottom of pan, bottom of pan gain thermal energy. So the less dense warm, the less, sorry, the less dense warm, the less dense warm water will rise above it's the more dense. So cold water or the liquid causing the water particles to circulate. Yeah. Okay. State the temperature at which the water boils at standard atmospheric pressure. Of course, 100 degrees Celsius. Number 4, figure 4.1 represents a wave on the surface of water, right? This wave. Determine the amplitude of the wave in figure 4.1. Amplitude this amplitude. Okay. So 10, it means yeah, 15. Yeah. 15 centimeters. Determine the frequency of the wavelength first. The wavelength from this point to this point, this wavelength. Wavelength is 2. Okay. And then frequency equals wavelength over 1 over wavelength equals 0.5 hertz. 0.5 hertz. Figure 4.2 shows wavefronts passing through a small gap in a barrier. The arrows on the diagram show the directions of propagations of the wavefronts. This is the figure, right? State the name of the wave property shown in figure 4.2, of course, diffraction. Like C, figure 4.3 shows wavefronts changing directions as they pass from shallow water to deep water. The arrows on the diagram show the directions of propagations of the wavefronts. State the name of the wave property shown in figure 4.2. Different this figure and this one. If this is diffraction, and this one is a refraction. Double I. State one property of the water wave other than direction that changes as it moves from shallow water to deep water. So what happened uh, can affect to the direction. Okay, that is change the speed or velocity. Change it, speed or velocity. So it would be affect to the wavelength. Five, figure 5.1 shows the main regions of the electromagnetic spectrum in order of increasing frequency. Right. So after radio waves, this is microwaves. While this one X-rays. Yeah, A already. The state one use of infrared radiations and one use of ultraviolet radiations, right? This is for infrared, used for TV's remote controller. While ultraviolet radiations sterilizing water or food. For example, mineral water. She described possible harmful effects of excessive exposure by infrared radiation and ultraviolet radiation. So it's danger for our skin. Because it our skin can burn. Ultraviolet, it can damage uh, it, our skin as well. Is implicated in skin cancer. And for our eyes, implicated in cataract. Yeah. Number 6, figure 6.1 shows 4 wind turbines. So wind turbines describe how a wind turbine generates electrical power. So 6a, as the wind blows, it rotates the blades, okay, and turbine automatically spinning. So generator will rotate and produce electrical power. The electrical power output of a wind turbine is 624 kilowatts. The output current is 520 amps. Calculate the output voltage of the wind turbine. Okay, so voltage formula is power over current. So it becomes 6 to 4 kilowatts over 520 amps. Or I'm going to change this, becomes 624,000 watts over 520 amps. It is 1,200 volt or 1.2 kilovolts. For transmissions, the output voltage is increased 132 kilovolts. State 2 advantages of transmitting electrical power at high voltage. Right. Number 1, it is more efficient. It is more efficient due to as lower current due to as lower current flowing through the power flowing through the power lines result in less heating being reduced energy losses. Number two, this is number one. Number two, based on formula, V equals P over I. If V increases, if I will decrease. Decrease. I will, sorry, double will. I will decrease okay, to trans to transmit the same power. Same power or energy. Of course, electrical energy. Number seven, figure 7.1 shows a ray diagram for an object position on the principal axis of thin converging lens, right? F1 and F2 are the focal points, right, of the lens, and C is the center of the converging lens, right? On figure 7.1, each small square of the grid represents 1 centimeters. Determine the focal length of the converging lens. Okay, focal length, okay, this is F2 and F1 are our focal points. So focal length is 1, 2, 3, 4, 5, 6, 7. Yeah. So it's 7 centimeters. On the figure 7.1, draw an arrow to show the positions of the image formed by the converging lens. This one. This is the image. Okay. State three characteristics of the image formed by the converging lens. So one, the image is real. Two, the image smaller than the object. This is the object. Okay, so the object greater than the image, and then C, inverted position. Look, inverted of the object. Number 8, figure 8.1 shows a solenoid long coil of wire connected in a circuit. When the switch is closed, it means electricity flowing. There is a large current in circuit. Okay. Describe an experiment to identify the pattern and the directions of the magnetic field around the solenoid. You may draw on figure 8.1. Okay. If there is going to use magnet, of course, this is north side and south side. So will be like this, the patterns or the direction of the magnetic field. Okay. Yeah, like this. Okay. From north to south. Okay. Now B. A solenoid is placed close to another solenoid Q. Solenoid Q is connected to a sensitive voltmeter. This is the voltmeter. The arrangement is shown in figure 8.2. Describe and explain what happens when the switch is closed. When the switch is closed, the electricity flowing, and we are going to explain the implications for uh, the circuit solenoid Q. Right. Uh, R voltage, R voltage generated in coil Q causes pointer on sensitive voltmeter on sensitive voltmeter. There is a voltmeter on a solenoid Q. Yeah. So the pointer moves because of EMF inductions. Yeah. Electromotive force. Yeah. So if current steady there, uh, if current steady there is, yeah, if current steady, I mean, there is no effect for for magnetic, for magnetic field change. Number 9, a student investigates an electric current. Figure 9.1 shows the student's circuits. Okay. Describe the purpose of the variable resistor. The purpose of variable resistor is the variable resistor uh, can be changed, can be changed can be changed uh yeah can be changed voltage and current as we need. Yeah. So it functions to regulate the amount of uh, yeah, this resistor, variable resistor functions is to regulate amount of electricity current and voltage. I'm going to add here. Regulate amount of electricity electricity current and voltage as we need. Two, the students uses cells with an electromotive force, EMF, 1.5 volt. Determine the number of cells needed for 6-volt battery, right? So number of cells equals 1.5 volts over 6 volts. It is 4 cells. The solution is 4 cells. The students connect another component to measure the potential difference across the heater. Draw the electrical symbol and connections for this component. So it attaches potential difference. It attaches potential difference or voltmeter. Yeah. Wait. So we are going to attach voltmeter on that circuit. Of course, voltmeter here. This voltmeter. Okay. And this is the rheostat or variable resistor. The potential difference across the heater is 4 volts. The current in heater is 1.6 amps. Calculate the energy transferred electrically by the heater in 40 seconds. Right. The formula is E equals V times I times T, or 4 volts times 1.6 amps times 40 seconds is 260 joules. 260 joules. Then, a nucleus of an isotope of actinium contains 89 protons and 136 neutrons. The chemical symbol of actinium is AC. Complete the nuclide notation for this isotope actinium. Okay. So, right. 225 here because it's 136 minus 89. Yeah. It is, plus, 5. And then this is 2 as well. So 225. And this is 89. State the number of electrons orbiting the nucleus of a neutral atom of this isotope. Right. This number of electron, 89. A sample contains 8 milligrams of this isotope of actinium. The isotope of actinium has a half-life of 10 days. The graph of figure 10.1 shows the original mass of the actinium in the sample and its mass after 10 days. On figure 10.1, plot 2 more points for the mass remaining after 20 days and 30 days. Draw the decay curve for the sample over 30 days, right? So 20, it means half of 4 becomes 2. So here, the points, and then 30, half of 2 is 1. This, let's we sketch, going to using this color. Okay, so the graph like this. Okay, connect all coordinate points. 11, figure 11.1 represent the sun and the part of the solar system. Complete the labels on figure 11.1 by writing on the dot lines, right? So this is Venus, yeah, Venus, and then this is, of course, Moon, the Earth Moon, and one, the Earth. We complete the sentences about the sun. The sun consists mostly of elements hydrogen, and helium. Okay. Helium. Most of the sun energy is radiated in the infrared. Okay. And ultraviolet. Infrared radiation, I mean here. Radiation or light, yeah. Next, give an estimate for the diameter of the Milky Way. 100,000. Okay, students, thank you for joining with me in this lesson. Please review your lesson when you learn in school. Thank you. See you